Welcome, developers. Today we are focusing on the unsung hero of LangChain, the Runnable protocol, specifically its powerful standardization of input and output interfaces. Let's get started. Let's define what the Runnable protocol is. When building AI systems, you interact with many different pieces, prompts, LLMs, retrievers, and parsers. Historically, each of these had different methods for execution. The Runnable protocol changes this by establishing a shared specification for all components. It standardizes how data flows into and out of an object. The basics revolve around three primary methods: invoke for single inputs, batch for multiple inputs, and stream for iterative outputs. Furthermore, to support modern, non-blocking application architectures, every single one of these synchronous methods has an asynchronous equivalent, such as invoke or a stream. This universal contract means that once you know how to execute one LangChain component, you know how to execute them all. Let's examine this class diagram. At the top, we have the Runnable interface, acting as the blueprint. It strictly defines the required execution methods: invoke, batch, stream, and their asynchronous counterparts. Below it, you see diverse components: prompt template, chat model, and output parser, all inheriting from this exact same interface. This visualizes how the framework guarantees that regardless of the component's internal complexity, its external I/O execution signature is completely standardized. Why did the developers of LangChain invest so much effort into standardizing these input and output interfaces? The primary motivation is creating interchangeable building blocks. Imagine you built an application using an OpenAI model, but business requirements shift, and you must migrate to a local Hugging Face model. Because both models adhere to the exact same Runnable specification, you simply swap the component object. Your execution code calling invoke or stream remains perfectly intact, future-proofing your application. Furthermore, because the I/O interfaces are unified, LangChain can inject universal utilities across any component. You can seamlessly add automatic retries, configure fallbacks, or bind runtime schemas to a prompt just as easily as you would to a vector store. It elevates your code from fragile, custom scripts to a robust, managed execution plan. This flowchart highlights the power of interchangeability. We start on the left with a standard input. This input hits the central Runnable interface hub. Notice how this hub effortlessly branches out to entirely different backends: an OpenAI LLM, a local Hugging Face model, or an Anthropic LLM. Because they all respect the protocol, the output generated on the right is always formatted as a standard output. The surrounding application doesn't care which path was taken. Let's look at how we actually utilize these standardized interfaces in practice, focusing on invoke and batch. The invoke method is your standard execution command. It transforms a single input into a single output. If you pass a string into a model's invoke method, it returns a single message object. But what if you have 10 questions to process? Writing a manual for loop to invoke them one by one is inefficient. This is where batch comes in. The batch method efficiently transforms an array of multiple inputs into an array of multiple outputs. Looking at our sample code, calling model.batch, hi there, by hands the entire list to the framework. The framework automatically optimizes the parallelization, processes both strings simultaneously if the provider allows, and returns a perfectly ordered list of outputs. You get enterprise-grade concurrency with a single, standardized method call. Here we compare the execution paths of invoke and batch side by side. In the top container, the invoke method takes one single input, processes it through the Runnable, and yields one single output. In the bottom container, the batch method accepts an array of 3 separate inputs. The Runnable consumes them all at once, parallelizes the workload internally, and outputs a consolidated array matching the input sequence. It abstracts away all the complex parallel programming. Now for a deep dive into the stream method, which is arguably the most critical I/O interface for user experience. Large language models can take seconds or even minutes to generate long responses. If we use invoke, the user stares at a loading spinner until the entire generation completes. The stream method solves this by streaming output from a single input iteratively, piece by piece, as it is produced. You iterate over the response, rendering tokens instantly to the screen. But what makes the Runnable protocol brilliant is its graceful degradation. If you call stream on a component that does not natively support iterative output like a simple dictionary format, the standard interface won't crash. Instead, there will simply be a single part yielded that contains all the output. The standard I/O contract remains intact, ensuring your application architecture never breaks just because an underlying tool lacks streaming capabilities. This sequence diagram illustrates the real-time flow of the stream method. The user calls stream on the runnable, initiating generation. Instead of waiting for the end, the model generates chunk 1, which the runnable immediately yields back to the user. This cycle repeats for chunk 2 and so on until chunk n. The user receives a continuous flow of data, keeping the interface highly responsive. In modern software development, blocking the main thread is a cardinal sin. This is why the protocol guarantees asynchronous equivalence for every standard method. By using invoke, a batch, or a stream, your application can handle thousands of concurrent AI requests without freezing the server. But what if you have a custom, generic Python function like a data cleaner that needs to fit into this standardized pipeline? Standard functions don't have an invoke or a stream method. Enter Runnable Lambda. When you add generic functions to these standard graphs or chains, they are automatically converted into Runnable Lambda objects. This conversion is magical. By simply wrapping your custom code, it instantly inherits the standardized I/O interface. It suddenly gains the ability to process batches, execute asynchronously, and seamlessly integrate into LangSmith's built-in tracing and debugging networks without you writing a single line of infrastructure code. This diagram shows the transformation process. We start with a plain, standard Python function at the top. By wrapping it inside a runnable lambda, the function is upgraded. It radiates downward, instantly inheriting the standard invoke, batch, and async stream methods, as well as enterprise observability features. Your simple script is now a compliant, robust component. Let's apply this to a real-time, highly impactful use case, resilient batch processing for customer sentiment. Imagine your e-commerce platform receives 10,000 reviews overnight that must be translated and analyzed. Doing this sequentially with a basic for loop would take hours, and a single API timeout would crash the entire job. Because we understand the Runnable protocol, we solve this elegantly. We feed the entire array of 10,000 reviews into the batch method. The framework handles the asynchronous parallelization automatically. Furthermore, because operational utilities are standardized, we simply append with fallbacks backup model to our Runnable. Now, if the primary LLM throttles or fails on review number 4000, the standardized interface catches the error and seamlessly routes that specific input to a cheaper backup model. You achieve massive throughput, parallel execution, and flawless fault tolerance, all because the input and output interfaces are strictly standardized. Follow the data in this real-world flow. An array of 10K reviews enters the batch method. The method parallelizes the requests to the primary LLM. Most succeed and flow directly into the processed array. However, if an API error occurs, the dotted line shows the standardized fallback intercepting the failure, routing it to the fallback model, which recovers the data and perfectly inserts it into the final processed array. To wrap up our deep dive, remember that standardizing input and output interfaces is not merely a syntactic convenience, it is the foundational architecture of robust AI engineering. By ensuring that every single component from the simplest prompt to the most complex LLM speaks the exact same execution language, you unlock massive scalability. Orchestration frameworks like LangGraph rely entirely on this standardization to confidently pass state between autonomous agents. It also guarantees perfect observability. Because I/O is uniform, tracing tools can monitor every node seamlessly. You are no longer writing brittle scripts. You are engineering enterprise-grade, future-proof AI systems. Thank you so much for joining me in this session. I want to invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. See you in the next video. Our final diagram is a mind map summarizing the massive impact of standardized I/O. Radiating from the center, we see how this single design choice enables seamless component swapping, native parallelization by a batch, real-time UX by a stream, enterprise observability, and advanced orchestration. It is the core pillar holding up the entire modern AI development ecosystem.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. We have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. If you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks, you can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.